The pitch tool is used for detecting pin pitch or pin width. It finds the minimum and maximum pitch in the target and then compares the greatest variation in pitch to the average pitch of the master image. The matching rate can be scaled to display a numerical value in millimeters. Note, this is not a measurement tool, but used for detecting between different sized parts or okay, no good parts. Let's go through an example. I'm going to use this pitch tool simulator file to walk through step by step how to set up the pitch tool. First, let's go to sensor settings. As you can see, I already have my master image saved, and I have a part that contains 5 different pins. In my case, I want to make sure that these pins are straight and equally spaced and not bent or damaged. So I'm going to jump to step 3 and add a tool. And under the Extra 1 tab, you can find the pitch tool. Next, it'll ask which direction you want to find the pins in, so horizontal or vertical. In my case, I'm going to select horizontal, and you'll notice it gives me this yellow rectangle on my image. This is my tool window that I can expand to cover the features of interest, which in my case are these 5 pins. Note that you want to keep the size of the window narrowed in on the region where a change is most likely to occur. So for me, that's going to be at the top of my pins. If I expand my window to cover the entire part like this, it will be less sensitive to detecting a change that may occur up in this portion of the window, just because all of this area down here remains the same for my good and bad parts, which you'll see as I go through my sample pieces. But I'm going to leave my tool window size right about here. And you'll notice it places a green line with a green arrow showing what pitch or width it's currently picking up on. And right now it's giving the pitch between these white spaces, so not the actual pins of my part. If I jump to the extended functions right away, you'll notice there's a bright/dark mode. I'm currently on bright, but if I change this to dark, now it's actually giving me the pitch between my pins. So I'm going to keep it there. Next, you have your edge sensitivity settings. So if you go ahead and click this, you'll get a graph with peaks that show the intensity of the edges that this tool is seeing. You'll see 2 peaks per pin for this first edge and then the second edge. You can adjust this sensitivity threshold here to either allow for additional edges or exclude edges. But here I have pretty good contrast between the white and the black, so all of my peaks are quite intense and I don't really have any sensitivity to adjust for. I'm going to hit OK here. And lastly, you have your limit adjustment. So this is just to determine what is considered good and bad. I'm going to go ahead and raise my thresholds to about 90 and 110. And so anything within this range would be considered a good part. Anything outside of these thresholds would be considered a bad part. So now the basics of the tool are set up, but let's hop into the extended functions just to go over some of these more advanced settings. So we already touched on the bright/dark mode. You can see how that changes here. The next one is the measurement mode. So by default, it will be pin pitch, but let's say I wanted to detect the pin width instead. If I zoom in, you can see now it's actually giving me the width of my pins by detecting these 2 edges, and you can see the arrow in between. In my case, I want to keep this on pin pitch. The next setting is narrow pitch mode. So if you go ahead and simply enable this, you can see my graph for the sensitivity of these edges has become much more narrow, whereas when the setting is disabled, these peaks are a little bit wider. This setting you'll want to enable if you're inspecting narrow pitches. That way, the tool will be able to easily identify different edges even when they're close together. In my case, my edges are not that close together, so I'm just going to disable this and hit OK. And lastly, you have your scaling settings. So if you want to scale your matching rate to be a display value in millimeters, you can go ahead and enable that here. So for example, if I knew my pin pitch was 10 millimeters in my master image, I could go ahead and set that display value here. If I hit OK and jump back into my main settings tab, you'll see my limit adjustment is now 9 to 11 millimeters as opposed to 90 to 110%. I'll go ahead and hit OK and complete my program. And now let's hop into operation simulation to test out how this tool would perform on other targets. So as you can see, I have various targets saved in my image history. And as I click on each one, you can see my pitch tool. It finds the minimum pitch, the maximum, and lists that here as an OK part. As I click through here, you can see in this example, it is finding the minimum pitch of 8 millimeters right on the left side. And it's also finding a max of 11.45 millimeters here. So that is considered a no good part because that pin is bent. As you continue going through these examples, you can see how the result changes. In this example, because my tool window has protruded outside the field of view, I'm getting dashes and it's not able to read that part. But as you can see, this pitch tool is able to correctly detect when a pin is bent versus when it is straight for a good part. I hope this video helped explain how to set up and use the pitch tool, but if you have any additional questions, please give our tech team a call at 888-KEYENCE option 2 for tech support. Thanks and have a great day.